Good afternoon and welcome to today's International Space Station program briefing, where we're going to bring you up to date with plans for upcoming spacewalks aboard the International Space Station. With us today we have International Space Station Program Manager Mike Sefredini and Courtney McMillan, the lead flight director, who will be handling the spacewalks as they progress. We'll start off with some comments from Mike and Courtney, and then we'll move on to your questions. Mike?
Good afternoon. Saturday afternoon, later in the afternoon Central Time, we lost one of our external active thermal control cooling loop pumps. We refer to them as PMs, or pump modules. This was the pump that's on the starboard truss, S1 truss, that flew up to the ISS and was installed back in October 2002. At that point, we activated the pump but did not drive the motor to start pumping the ammonia. As you might recall, that was the early phase of the assembly of the ISS, and we weren't ready to flow the ammonia to do the cooling of the bigger power systems until later. And in fact, in the December 2006 time frame, we flew the 12A.1 mission. The significance of that mission to us at that time was when we actually configured the power system and activated the cooling system. At that point, we started driving these pumps. And all that's important information because as we do our failure analysis, it's about the operational time on orbit that helps us decide mean time between failure and see if this failure has any effect on that. As a result of that anomaly, the ops team did a fabulous job of reconfiguring the vehicle, shedding loads off of that thermal system, and either powering off systems or transferring the load to the other power strings that were cooled by the B pump on the port side of the vehicle. So you probably heard during that period that we shut down 2 CMGs, we shut down a GPS system, we shut down S-band string 1, a number of MDMs were powered down at the time, and many heaters were also deactivated. Once the configuration was stable, then the ops team did attempt to reactivate the pump in the possible event that it was some sort of radiation hit or momentary hit in the system, and we did try to power it up. And the circuit breaker tripped again right as we sent the command to bring the RPMs up. The data suggests that the motor and impeller are not frozen. In fact, the motor did start to pump some of the ammonia when we tried to start it the second time. So this tells us that there's a short somewhere in the power feed to the motor between the controller and the motor. All of that is encapsulated in what we call the pump modules, a very large ORU on the truss that we will now have to replace. After we finished that effort and the team got a chance to see that the loads and the heat on the DDCUs that were not being cooled were lower than we expected, we slowly over time have activated some of the other ORUs we powered off. We only have 1 CMG powered off at this time. All but 1 MDM is up. Both the S-band strings are available for use. We still have a number of heaters powered off, but they're available if we need them. So the position we're in today is actually fairly close to nominal relative to the systems that we have up. Of course, some of our payload racks did have to get powered off. Many of them are on. We did have to turn off one of our freezers, which have specimens in that we have to bring home. But before we powered that one off, we transferred all the specimens into one of the Melfi freezers, and that one has been provided power for almost the entire time. I think it was off for a short period of time, but it has about an 8-hour limit, and so we never approached that. So all the specimens on board have been protected. Since the next failure of a pump module would be a relatively significant challenge for the program, we asked the team to redirect the EVA planned on Thursday to do the pump module R&R. We have 4 spares on orbit pre-positioned today. In fact, those are all the spares that the program has, and this is part of the process. We've implemented over the last several years to try to pre-position as many of these large ORUs as we can before the shuttle stands down. And though it's not really pertinent to this particular anomaly, we've gotten enough questions that I'll also tell you that these pump modules can fly on either the HTV or the SpaceX vehicle if we needed to fly one. Again, all of our spares that we had planned to build for the program have been flown and are on orbit. So Courtney and her team have been working hard, and she'll tell you all about what they've done to get ready for this EVA. But they do think they can be ready by Thursday, so that's a dramatic change to the EVA, but they still think they can get it done in time for Thursday for the first EVA day, and this is be a 2-day EVA, so the second EVA day would be Sunday. I did talk to the crew this morning, and as Courtney said, she just finished talking to them as well. They're in great spirits, they're ready to do this EVA. They had actually about a year ago trained. This is what we call one of the big 14 EVAs, which to date we hadn't had to do yet. It's Big 14 refers to some of the major ORUs that an increment crew might have to do without the shuttle vehicle there. So some of the crew, we don't train them all. The crews train generically for maintenance and then train for some of the Big 14, and this particular one the crews did train for. So they have some familiarity with the tasks that is being asked of them. The ops and engineering teams, because of the fact that we're down to one cooling pump, we've got the ops and engineering teams now full up for 24-hour support. Looks more like a shuttle flight over in the control center if you go over there and look around. Before I hand it over to Courtney, I do need to say that we spare the vehicle and we train the crews and the teams for these kinds of anomalies. We have been very fortunate in our lives to not have to deal with too many real significant anomalies such as this particular pump module. But the team is ready to go, and as Courtney will tell you, we've got good plans in place, and we'll go get this R&R done and then move on more to a nominal research planning, which of course is probably the biggest hit to the program to date, will be the amount of research we're able to do for the next several days. So with that, I'll hand it over to Lead Flight Director Courtney McMillan.
All right, good afternoon. So as Mike said, we had an EVA planned for Thursday that had a completely different timeline. We went ahead and started working options to see if we could get the pump module R&R started on this Thursday, and we are still in the process of doing that. We have crew members in the NBL today doing what we call a development run to see if we can, and we're getting some video now this is live from the NBL. This is Katie Coleman and Sonny Williams in the pool, and they are doing some of the tasks that we foresee on these two EVAs. We're trying to work out the details of the timeline, and based on how this run goes today, we'll be able to decide if we're really going to be ready for Thursday for sure, or if we're going to need another day or so to polish some of the constraints that we're working with and some of the steps we're going to need to do. All right, let's see. Let's go to the first graphic, and I'll show you what we're talking about today. So ignore the array on the top of the truss. This is an old configuration, but the yellow box there is the S1 pump module, and where it's located, this is the one that is in the system, and that's failed currently. And let's go to the next graphic. This is a closer shot of that, and you can see the ORU is pretty big. It's I think it weighs about 500 pounds. We can get the exact number for you guys later on. Next slide. This is the location of the spare we're going to be using on ESP2, which is on the other side of the truss, basically, so and down below as opposed to up on the face. So the crew has a fair amount of translation to do during this EVA. Next slide. This is a closer shot of the pump module itself, the spare. You can see it's got a grapple fixture on it, so we can either use the arm to move the ORU directly, or we can have the crew members carry it. The baseline procedure that we carry for generic training for the crew as part of the Big 14 training assumes that we do not have access to be able to use the robotic arm because of the loss of power redundancy on the external ORUs. So we are essentially right now running single string on the robotic system. We are in the process of doing some testing and analysis to see if we can get enough redundancy on the arm to be able to use the arm even if we have a failure for the full spacewalk. We know for sure we have enough capacity on the redundant power string to be able to use the arm if we needed to fail over and get the crew to safety while they're off of structure. So we do plan to use the arm for the EVA. It will be in a safe configuration, and it's really just we need to determine if we have enough margin on the arm, on the power system, to be able to use the EVA in the backup configuration through the whole EVA, or just to get the crew member to safety. There are a lot of technical challenges, as we've said, with this EVA. With these EVAs, it is a minimum of 2 EVAs to get the job done. The first EVA, the focus will be on getting the failed unit out. We hope to be able to prepare the spare unit for installation on the first EVA as well, but that is entirely dependent on how the timeline flows with some of the challenging parts of preparing the failed unit to be released. The most challenging in there is the ammonia quick disconnect connections that the crew is going to have to release. Since the external loop uses ammonia as the cooling fluid, all of the lines are pressurized with ammonia and have to be released by the crew during the EVA. We've done this before for different parts of the thermal system, and the crew is very well trained on how to do decontamination if they get ammonia on them during the procedures. But it presents a timeline challenge to make sure we have enough room in the timeline to account for that. I already talked about the power challenges. That's not just for the arm, but also for the preparation for EVA systems required as well. There are some timeline challenges. We're putting together, like I said, the robotic portion of the EVA. Shannon will be running the arm while Tracy and Doug are outside. And we are pulling those procedures together as well. So folks are working hot and heavy to get everything ready. For Big 14 failures in general, we typically allow for about 2 weeks to prepare for one of these EVAs. Since we had an EVA coming up, we decided to take advantage of the fact that the crew already has the airlock and all the suit systems all ready to go. But this is a very aggressive timeline for us to get the procedures ready. Folks are working around the clock, as Mike said, and doing an amazing job getting everything we need so that we can be ready to go. And let's see, we've got another NBL run either tomorrow if we decide we're in good shape to press for Thursday, or we'll slide that second NBL run one more day if we need to get some additional time to polish the timeline. And then that will be the final run prior to the first EVA. If we need to, we will do another run after the first EVA and before the second one, just to clean up the whole config and make sure we're good to go. And I think that's all I've got for a general briefing.
Okay. Thanks. We'll start out with questions here at the Johnson Space Center in Houston. Please remember your name and affiliation. Start in the back with Mark.
Hey, thanks. Mark Carreau for Aviation Week and Space Technology. Had a couple questions, and my first one deals with a sort of context for this. And I just wonder how you consider this in terms of urgency. Obviously, the preparations around the clock speak to that, and the near term for the spacewalks, but how do you sort of size up what this means to the space station in terms of its operability with 6 people and so forth?
Well, to some degree, it's independent of the fact that there's 6 people on orbit. There's a number of systems that need to be cooled, all of which, well, I shouldn't say all, some of the power modules cool themselves out there at the end of the truss, but the majority of the ISS systems are cooled by these 2 loops. So we have one loop down, as Courtney was telling you about the SSRMS ops. The DDCUs that provide the majority of the power to all the systems, they have some residual capability because they manage not to overheat at lower loads. So we are getting some use out of some of the DDCUs. Not all of them are able to do that, but some of them are. So if we lose the next cooling system, then we don't have the ability to cool most of the components on board ISS. And so that would be a significant challenge to the team to work through that. In order to work through that, you'd have to get the crew out to go do EVA and change out whatever component needed to be changed out. So the team just as soon not be in that position, and so that's why we've asked the team to take all haste to try to get this particular EVA done, so that we can put ourselves back in a redundancy position that gives us more time to react to the next failure. So really from an ISS perspective today, we're in fine shape. We're just trying to make sure we get the EVA done before we suffer the next failure in that system, which is, while very unlikely, is something we ought to do as a program to make sure we give ourselves the best chance of success.
Thank you. I had a second question. I believe you touched on this about the number of these pump modules. And I think you said 4, but I wasn't sure whether you meant the 2 that are operating plus 2 spares on the station, or if you in fact have 2 operating and 4 spares.
Yes, we have 2 operating and 4 spares.
And can you say where those are, where the spares are located?
I can. ESP2, ESP3, ELC1, and ELC2. All of those each have 1 pump on them.
Eric Berger with Houston Chronicle. So you're saying that the primary concern, and this is on the assumption that the second module fails, which obviously we talked about is unlikely, that the primary concern would be the frying of these components, or describe it how you will, on the outside, as opposed to the station overheating inside and being a concern for the safety of the astronauts. I guess I'm just sort of trying to understand how bad of a configuration you would be in if you lost the second one for a period of time.
Okay. The way the system works is we flow ammonia. The ammonia flows to through some components outside for cooling, and then it flows to a heat exchanger on the labs and the nodes that provide then cooling to a water loop that's inside. And so everything that sits on a cold plate is inside is also cooled by this same ammonia system. So all of the systems inside and outside, and so therefore also, I should say, the AAA fans that get their cooling, that cool the air, the systems that get air cooled, also get their cooling from this ammonia system indirectly through the water loop that flows through the inside of the space station. So all of the systems, other than some of the components out on the truss where the power modules are, get their cooling from this cooling system. Now you'd say, well, then you should be okay, you have power. The problem with that is the power comes in from the power modules and goes to 4 main distribution boxes called the MBSUs. Those get their cooling from this ammonia system, and then those all flow to DDCUs that get their cooling from the ammonia system, and so on and so forth. So without these pumps, without this ability to have ammonia cooling the system, then we get to the point where you have to start shutting things down. Some components do have some radiative cooling that can occur, but that's very minimal relative to the loads they're asked to carry. And so that just puts us in a very real struggle to keep all the components working. And the reason why I said it wasn't really crew independent, there are ECLS type systems that support the crew, the oxygen generation, CO2 removal, water systems, things of that nature. But if you lose all the rest of the systems, then really the life support becomes just one of the many systems you lost, and at that point you got to get the cooling system back so that you can bring up all the systems, including the life support systems. So and that's why I said it the way I did. Does that make sense?
That does make sense. And I guess, would it be a concern, so the crew short term, I mean, they're not going to be like burning up in there when they're in the face of the sun, and then the second of all, the components themselves, most of them wouldn't be fried if they lost cooling for a couple of days or two without.
Oh, you're asking, so what happens if I lose the other system before we, is that what you're, okay. So I can touch on pieces of that. Of course, remember we have the whole Russian segment, and it is independent of the U.S. segment in terms of cooling. And so we would hand over, they can provide some of the life support functions already. Most of their systems won't do 6 crew, but they'll do a subset of 6 crew. And so that's be the first thing you do. We'd hang as much as we could for life support on the Russian segment. The Russian segment would have to take over control of the vehicle. And that costs you about give or take 50 kilograms of prop a day to hold the stack in attitude. And then we've got quite a bit of fuel on board, so that's not a near-term issue. I think there's like 100 days, somebody said, something like that. So we got quite a few days of that. The bigger challenge then is power enough of the power systems that you need to go ahead and do your EVA and get outside. You need comm, you need power for some of the systems and things like that. We've asked the team, I say all this like I know exactly all the steps we do. One of the things the team is off doing now is giving us that rundown. What do we do if we do, in fact, have this next failure before we change out the pump? So there's a team that's been activated as of yesterday, and they're off trying to sort that all for us. But I mean, that's the Reader's Digest version. We put all the life support on the Russian segment. The Russian segment would struggle to provide for 6, but it could over several days. And then we'd go get this particular EVA behind us and get that pump back up. And then we would slowly go through the next step of recovering the other pump, whatever caused it to fail. Now, I don't have a reason to believe it's going to fail or any of the other systems, but that's just planning that we try to do to protect ourselves.
More questions?
Hi, Robert Perlman with CollectSpace.com. To start, to work off somewhat of what Mark asked about putting this into context, where does this failure sit within the 10-year history of the ISS with the problems as compared to like the problems you experienced with SARG, the problem you experienced with the CMGs? How critical is this compared to the other issues that the ISS has faced?
It's up there. Being external adds an element of challenge to the time frame to get the repair done. SARG was, though it was a significant issue for us at the time, we always had plenty of power. Remember, it occurred early in our life, and so we didn't need to rotate the array, and we knew that fairly soon. Now, we were worried about the long term, but there was an immediate challenge. Probably the other one that rates right up here is the solar array tear that occurred during 10A when we were trying to redeploy that one. And that was only because it took us a little while to figure out if we thought we could repair it at all. And though we acted very calm through that whole thing, that was a challenge for us. So this one is not. And that was an unplanned one. We really hadn't planned on tearing solar arrays. We didn't think it was one of those things we could do. We thought there were other things that would occur before you'd cause that to happen. So this is an anomaly we knew someday would happen. It's an anomaly that we have trained for. It's an anomaly that we have planned for. Obviously we've spared for it. So, I mean, we're in a good position to go solve this problem. It is a significant failure, though, in terms of systems on board ISS, and so it's one we need to go get after. But, you know, it's not a, you know, it's not, there's anomalies that are significant to you as a system that you need to get to quickly, and that's what this one is. There are anomalies sometimes that occur that you hadn't planned on, and then it takes you a while to figure out how you're going to go solve it. But that's not the kind we're dealing with here. So we're actually in great shape to have, as Courtney said, to have the EVA already planned. That is significant because there's quite a bit of work to configure the airlock, get everything set up for the crews to use the suits, and all that work was already, a lot of it done. There was probably a little bit left to do as we came towards Thursday. But that was really a blessing in terms of the time to get to this job.
Since, as you mentioned, this is a task that's been well rehearsed, well planned for, what are the potential snags during the EVA? Where would you expect if there was to be a hang-up in terms of removing or replacing the unit, where Doug Wheelock and Tracy Caldwell Dyson might run into the most trouble?
Well, we trained the Big 14 tasks primarily, like I said, task-based. So a lot of the choreography that goes into an EVA about which way you're going to maneuver and in what order you're going to do particular steps, that is usually not worked out to the level of detail that they can train that detailed timeline during their generic training. So a lot of what we're doing in the development runs are working out those details. The areas where we would more than likely run into snags have to do with when we're manipulating the ammonia quick disconnect plumbing to disconnect the actual failed pump module ORU. When we do the vent of that pump module, that we may run into some snags there, although that is something that's pretty well analyzed on how to do, so we're not anticipating any significantly different conditions as a result of that. It's just the actual execution of it, depending on how we do that and how we choreograph it, where we may run into some timing snags. So that's really what we're working on. Most of the rest of the task is just logistics. Like I said, this is a difficult box to maneuver with. It's a big, unwieldy object. So maneuvering it around and handing it off between crew members, if that needs to be done, depending on how we do the choreography, that could take some time. None of that part of it is technically difficult, but it's just very time-consuming and takes a lot of focus.
And just a quick follow-up on that. With regards to logistic support for the spacewalk, with all the power downs, can you use the cupola and robotics station for this EVA, or do you have to go back to the one that's in Destiny? What's the logistics inside?
We're going back to the one that's in Destiny. We actually, some of the units for video transfer that we need for the cupola workstation are not able to be powered in our current config, so we're not able to use the cupola. The cupola is on the other side of the space station than the truss segment that we're going to be working on, though, so that's actually not an impact for Shannon's ops.
Jim?
Jim over with NBC, and Courtney, you said it's a big unwieldy object. Would a third or fourth set of hands outside be of any help to you? Or have you been thinking of some of these out-of-the-box opportunities you have, considering who's on the station and who else is EVA trained?
We are not. We actually, Tracy and Doug are the U.S. EVA crew members who are EMU certified, so they're the ones doing this, and we have not ever discussed having a third person on this EVA. A third set of hands probably would not help us with this. It's really just a matter of choreographing who's getting the spare and then who's putting it in and that kind of stuff. Having the arm available, having the robotic arm available is a huge help, so that really is going to help us make some efficiencies in the timeline.
Well, I would like to ask more about the arm, because I was confused by your discussion about the arm is single string right now, and so your whole planning would have to assume at some point the arm may stop at any point in the operations.
That's correct. So if we hadn't had this failure and we were planning arm operations, we would be running it single string, and then if we had a problem with it, we would power up the second string and switch strings. So essentially, for any operation that we're doing with the arm, we would pause if we saw a failure, bring up the other string, and then continue operations. The analysis and the work that the engineering team has done over the last couple days has shown that we have flight rules in place that say it's okay to run uncooled DDCUs for a certain amount of time or to a certain temperature limit in order to regain functionality if you need it in a critical situation. So having a crew member on a robotic arm during an EVA certainly counts as a critical situation. So we would be able to power it up uncooled for a limited period of time, which is enough to get the crew member to safety. The team is continuing to do some testing and analysis to see if we can possibly rely on those DDCUs cooling themselves long enough to complete the EVA if we had that happen in the middle of the EVA. So at a minimum, we can get them to safety and pick up with contingency options for the completion of the EVA without the arm. We are hoping to be able to rely on the arm through the whole EVA.
This is an important point for us to make out here, because losing cooling does not mean you lose the power immediately. Right. Okay, that's the important
the power is still good. It's just a matter of can we manage the use of the power units that are uncooled to keep them from overheating.
And even if they do overheat, there may be a trade-off there.
Well, there's heating and then there's overheating. We know they will get warmer than they usually get because the cooling loop is gone. We think that, well, we know for sure that it's okay to run until we hit a certain limit, and that is certainly enough time to get the crew to safety. We think, and we're doing some testing to prove, that we should be able to manage running with the secondary power unit through the rest of the EVA if we had that failure. And once we know that, then we don't have to worry about contingency plans.
And a similar question for Mike on the issue of life support. Again, with the total failure of power on the U.S. segment, you still, considering the volume of the segment, you still have, what, 5, 6, 8 days worth of basic life support, and then just breathing the air that's in the segment before you start getting hazardous?
No, it won't be that long. PPCO2 will rise, but we have lyocans for, I think, 17 days. And so the Russian segment will be scrubbing at the max it can. We have a new Vozduk. We can install even more out of the Russian PPCO2 system. Oxygen will last, I don't know where we are. We'll have to look at where we are in oxygen, but usually we can get several days out of the oxygen. And of course, temperatures would slowly rise over time as well, but the Russian segment will be cooling the stack as well. So with the Russian segment running, we have quite a bit of time. I mean, multiple days, because the electron can be activated at a higher level. We've got an older electron in there, but there is a spare on orbit. As I mentioned, there's an older Vozduke in place, but we have a spare we can replace and give us more capacity. And of course, they can cool the stack as well. So really, from a life support standpoint, we'd be in good shape.
To continue to do the EVA, okay.
Right.
Where do I get a list of the big 14? Is there a list of them somewhere, or?
Oh, yeah.
I don't need it right
Yeah,
now.
we can get it to you. Sure.
Okay. And those are all the questions. I want to ask about the jumper cables later on, but that's an offline question too.
Okay.
Very good.
That's all of our questions here at JSC for now. We'll be sending folks out to Kennedy Space Center, but just as a little input, somebody asked earlier how much the ORU weighed, and total weight of that pump module is 780 pounds. So with that, we'll go ahead and go to Kennedy Space Center for questions from there.
Yes, hi, Marcia Dunn, Associated Press. Question for Mike to start off with. Assuming that you did not lose your second coolant loop, how long could you keep going along with the way it is today? If for any reason the spacewalk had to be put off, or you put in a new pump and it didn't work?
Indefinitely. We don't get, what we're limited now is how many systems can you run at any one time, and so research would be affected if we stayed in this position for a long period of time, because we can't operate as many racks as we'd like. In fact, I think it was last week, I'm losing track now, we had the most research racks up ever. I think we had 13 racks active at one time on board, which is just an amazing feat, and it shows that we are transitioning, as we said we would, to utilization environment. Well, that doesn't happen without more cooling, for sure. So it would limit our ability to do normal research, but there's no risk to the rest of the systems. Now, we'd have to work separate failures after that and things of this nature, but we could go for, like I said, indefinitely, as long as you didn't lose the other loop.
And right now, are you doing any science up there? I'm wondering, or has all that been curtailed? And also, how sure are you that another pump won't suffer the same problem?
Let's see. For the first answer, it's very limited, partly because of the fact that we're focusing the crew's time on preparation for the EVA. But we also have some racks that are down. Not many, but some that are down. We could get you specifics of what's going on, but it is very limited, and mostly, again, because the crew is focusing on getting ready for the EVA. So they have to study as well. They've got a QD training board up there, mock-up, that allows them to practice with the ammonia QDs and things of this nature. So they're busy getting ready for the EVA. And what was your other question? I'm sorry, I forgot.
How are you sure that another ammonia tank won't another pump won't just trigger another circuit breaker failure?
Yeah, I'm sorry. You didn't say it so long ago, I shouldn't remember what the question was. I'm not, but I can tell you that the mean time between failure suggests that we shouldn't be experiencing one anytime soon. So it's like anything, Marcia, you can't guarantee any system's going to keep running. And so for systems like this that are where the next failure is significant to you, then you try to get outside and do your EVAs as soon as you can. So if Courtney comes back with the team and says we need 2 more days to get ready for the EVA, then what we'll do is grant her 2 more days, because you need the team to go out there and do the job as safely as humanly possible. And you accept that that's well worth the risk, instead of rushing them out the door and having a problem because you didn't think it all the way through.
And for Courtney, I'm wondering, what is the distance between the failed pump and where the spare replacement part is located, and if you could just estimate in feet? And when do you expect a decision on whether Thursday is going to be a viable option for the spacewalk?
I'm going to need to check on the distance numbers for you. I would estimate about 30 feet, but I need to double check that. Let's see, and in terms of whether or not, or when we're going to decide about Thursday, we're going to have a first assessment of that today after the completion of the NBL run, so later this evening. And I expect we'll make a decision about that either tonight or tomorrow morning.
Hi, this is James Dean from Florida Today. Mr. Suffredini, you were describing things as being near nominal in terms of operations in the current configuration, but we're talking about a failure that affects like half the U.S. segment system. So I'm just wondering if you could compare a little more like what life on the station is right now for the crew in the U.S. segment versus what it would be normally if there are more lights out or more certain modules that they won't go into, or that certain facilities within them that can't be used, things like restrooms or sort of stuff that's part of their daily routine.
Yeah, near nominal is not a phrase that I would use to describe where we're at. What I would tell you is all the critical systems are operational, and in fact, many of the non-critical systems are operational. So none of the modules are closed and locked up with lights off, but for instance, we have 2 cooling loops in the Columbus module. We do have one of the pumps off in the Columbus module to preserve the power that we would otherwise be consuming with that. The same is true in Node 2. One of the 2 coolant loops is powered off. It's available if we need it, but it's powered off right now. So unnecessary lights are off, unnecessary heaters are off, things of this nature. But we don't have any restrictions, if you will. It's really today, it's about managing power on the good side, because you only have so much that you can provide and then therefore cool, and utilizing power on the failed pump side down to a minimal number that we don't overheat the DDCUs, and we do that in a few cases, not many. So I'm trying to leave you with the idea that everything the crew needs to survive, they're in good shape. All those systems are active. And what we're talking about really is it'll be a significant challenge if we suffer the next failure. But it's not normal, because we can't do normal operations with these power downs and the fact that we need to get on with the EVA. The crew's really focused on this EVA, as is the team. And so it's not. I wouldn't describe on orbit as normal as much as focused on a significant EVA that we need to get done.
Thank you. And I was wondering if the tasks that are being deferred from the originally scheduled spacewalk, do those need to be required before 133 arrives, or is that something that could be added to the 133 timeline?
We have one of those tasks was one we need to do before we installed the PMM. There's a connector that is necessary to allow us to change out, if you can believe it, change out a heat exchanger on node 3 should that ever become necessary. That connector plugs into an area that we won't be able to get to once the PMM is installed. And so what we'd like to do is get that connector, the plan, one of the tasks on this EVA was to connect that connector up to that location, and then we would just wire tie it out of the way somewhere, and then it'd be available for use with node 3 if we ever had to do the heat exchanger change out. So we would still have that in front of us to try to do before we install the PMM, and we'd talk about when's the right time. Today we don't have an EVA prior to PMN, so this was it. So we'll have to, think about where that might fit for the future.
Thanks. Finally, for Courtney, I assume talking about a minimum of 2 EVAs, that we're talking about sort of a standard 6.5 hour type length for each of these, or obviously depending kind of how they go each day. But is that the nominal plan, or?
That is the nominal plan. It's going to depend on how they're doing. It's going to depend on consumables, and it's going to depend, again, since we're manipulating ammonia connections, it's going to depend on making sure we allow plenty of time to clean up any ammonia that the crew is exposed to during the EVA.
Okay, I understand that's all of our questions from Kennedy Space Center. We'll go out to NASA headquarters in Washington, D.C. and take questions there next.
Okay, this is Mark Matthews with the Orlando Sentinel. Thank you, guys. Had a quick question. Are you guys looking to bring back the broken pump module on the Discovery flight?
Discovery flight, I'm sorry, I'm drawing a blank. Which flight is Discovery? Is it the next one? 133, no. It won't, well, the probably easier answer would be to say it won't fit on the next 2 flights. We don't have, you need a fairly large carrier to carry this thing home, and so you can't just pluck it anywhere. So the next 2 flights are not conducive to returning the pump home.
Does that mean the possibility if the White House and Congress decides to go with the 3rd flight, could it potentially find a home on that flight?
Yes.
Okay. And then just another follow-up. Is the Russian segment on a separate cooling system?
Correct. We do provide some power to the Russian segment, but the Russian segment cools itself, and so we're relatively independent in that respect. In fact, the Russian segment is completely independent. We provide power for a number of reasons. Part of the configuration for the FGB always assumed that we would provide power, and so if you look at pictures of the ISS today, you'll see the solar rays on the FGB are retracted. So we provide power for the FGB. In addition, we provide power to the service module as it picks up more and more task, and the solar rays on the Russian segment degrade a little over time. It's beneficial. Also, they can't quite point theirs as efficiently as we can point the big solar rays, and so it's more convenient for us to provide them the power. And so if we get to the point we have to completely shed all power, they would have to make some changes as well, and we'd probably point the vehicle a little bit different during those periods as well to provide them maximum power. But they do all their own cooling.
Okay, and then just a final question. Could you go in a little bit more detail about which experiments have been affected by the knockout of the one cooling system?
The only research, well, let me think. One of the Melfi freezers was shut down. We took out all of the samples from that freezer and put it into the one freezer that's active. The combustion rack has been shut down. And there was a 3rd rack, and it evades me right now. We can get that information for you.
Okay, that's all of our questions from Washington. We do have several reporters on the phone bridge. We'll start first with Ken Chang from the New York Times.
Yes, hi, thank you. What was the expected lifetime of these pumps? Is this sooner than expected for a failure?
The design life was intended to be 10 years. The MTBF, the mean time between failures, was estimated to be about a little over 100,000 hours. And this one had about over 50, probably closer to about 58,000 hours of runtime with the pump running. It's been active since it was installed, but without the pump running, so the electronics were active. And there's about 30,000 plus hours. So depending on how you look at it, there's about 80,000 hours worth of time on this particular pump. And so from an MTBF standpoint, this is a little bit early. And it's a first failure too, which is a big driver to figuring out how good you're doing on your MTBF number. So it's a little bit, I'd say it's early, yes. From a failure standpoint, it's early. On a whole, from the ISS standpoint, we have been much more reliable in our systems than we had expected. While you have design lives for many years, when you look at your mean time between failures, you build a sparing philosophy based on your mean time between failures and life, if your design life is less than the design life of the system. And so we spared that way, but this is a little bit early than we expected on the pump.
And if everything goes as planned, when will the station be back to full operation?
The team is currently working on, in addition to the EVA and the next worst failure options or cases, the team is also starting to talk about what the restart procedures need to look like. So it will certainly not be immediately after the pump is installed. We hope it will be very soon after that, but we don't have a timeline put together yet for the restart activities that are going to be required.
Thank you.
Okay, that's all the questions from Ken. We'll move on to Tarek Malik with Space.com.
Thank you very much. It's Tarek Malik with Space.com, and I have a question and a couple of follow-ups. Courtney, you mentioned how bulky the pump module is, and I'm wondering if you can kind of compare that to maybe pushing a double-wide fridge. Is it something kind of on that level? Is it bigger than that dimension-wise? If you can kind of give me a picture, that would be great.
I'm trying to remember from the pictures that we've had. Again, I'll look up the dimensions, get you those numbers afterwards. It's when the crew is holding it, it's something about like this big, so about like 3 feet across on the side that they're holding it. So it's probably like 3 feet by 6 feet, somewhere in that ballpark. It is very big, and it's like I said, it's unwieldy to maneuver. So a lot of the maneuvering is going to require a second person either to kind of spot and watch where they're going, or to actually assist with the maneuvering. So it's going to be a tricky choreography for the two crew members to do.
Thanks. And I was curious also if there's an estimated cost for the individual modules, and if they can be sent up on other craft beyond the shuttle, would you be ordering another one to have a full set of spares in the eventual future?
Well, our planning for ISS, as I said, assumed you take the MTBF, you take what you decide is the life of the ORU based on the verification work you did, and then you spare the program accordingly. So our analysis said we needed 3 spares. We built 4 for margin, and as I said, those are all on orbit, and we can fly them up on other vehicles if we built one. With this failure, where the team is off thinking about should we design a pump that has redundant pump motors inside? And so we haven't asked the team to go off and build a new pump. We do have a development pump that is available that we probably could do some work on and make it available. But the first thing we're going to do as a program is go off and look at at a possible redesign that would give us redundancy inside the pump. And so that's what we've asked the team to go do. Now, we just asked them to do that, so it'll be a little while before we figure out, A, if we can do it, including getting the redundant power then out to the pump, and then B, what the cost would be in the schedule and things like that. But that's what we've asked the team to go look at.
Great. And is there an estimated cost just for these pumps that are on orbit now?
I'm sure there is, but I don't know what it is off the top of my head. We can get that for you.
Thanks. And just my final question, then, you mentioned just the life on board the space station and the jumpers and whatnot. I'm just curious what it's like with those jumpers in place, if it's a little bit harder to move around inside, or are they pretty much out of the way and it's unaffected? Thank you.
They're certainly not invisible, but they are relatively easy to keep out of the way and essentially keep your activities out of the way of them. So we haven't heard any significant impacts to day-to-day life from the crew for having those there. And like Mike said earlier, having those in place really gives us the redundancy that we need to proceed with EVA and other critical operations.
Thank you.
Okay, I believe we have one other reporter on the line, Irene Klotz.
Thanks very much. Mike, do you think that there's going to be any impacts to the STS-133 flight with having to reschedule the EVA that was going to be done this week?
I don't know, Irene. I mean, it won't change the launch date, if that's what you mean, but we just have to go look to see where everything falls out, and there's quite a bit of time between now and then. If we feel like something's critical, it needs to be done, then we'll, before the flight, and we can't figure out how to do it during the flight, then we'll figure out how to do it before they get there. But that is something the team's off looking at, but I don't know enough yet to tell you how that's going to shake out.
Okay, thanks. And then the other question is, with considering the failure was a little early, and sounds like it's kind of unusual if you still have the motor working. How important is it to you to try and get this failed pump back?
Well, the engineer in me wants all of our ORUs home. The program manager in me knows that you can't get them all home. And even if you brought them all home now, you probably can't afford to tear them all down and figure out what happened to every single one of them. But very much so, it'd be nice to get this one home for the reason you stated. It's a little bit early in its life to be failing. And so to the extent that you could figure out what the anomaly is, and decide if it has any significant bearing on your MTBF number and therefore your sparing needs, that would be great data to have for that purpose. Otherwise, we'll just work the statistics of the failure and modify our MTBFs and then look at our sparing associated with that. Probably most importantly, though, is when you can figure out these kinds of anomalies, you can figure out what effect it would have on on redesigning that pump, but also on other systems you have. Designs, I won't say are common, but we use similar techniques. In fact, we work very hard to make sure we use similar processes in the build process to make sure we're using best practices. And so if we learn something from this, you could have the opportunity to look across your entire fleet and other things we do as an agency to see if we would do them different because of the particular failure. So we would very much like to get it home, but clearly if we don't get it home, we know how to react.
Okay, thank you.
Okay, let's come back here for a couple of follow-up questions at JSC, and then we'll wrap this up. Mark?
Thank you. From Mark Carreau for Aviation Week. I had two quick ones. For Courtney, I think, do you know the number of electrical and fluid connections involved in this?
On the electrical connections, I'm thinking it's 4 connections on the unit itself. I'll need to double check that. And it is 4 ammonia connections as well. And
will the spare that you used to replace, did that come up in November of 2009?
I don't remember when this one came up.
This is the oldest spare on orbit. I'm trying to remember which flight it came up. I think this one came up on 13A. I can't tell you the date of 13A, but I believe this one came up on 13A. Let me confirm that for you, Mark, before you set that in stone.
Yeah, Eric Berger with the Houston Chronicle. Just to confirm, the one module that is currently working, was that brought up in 2002 as well, and has been working the same amount of time, or?
The S1 and P1 flights flew right next to each other, and I don't remember exactly when we switched them early on too. I know when this one went up with S1 because I checked. They were right there. They were the last 2 flights we flew before the Columbia accident. So they were within a month or 2 of each other. So they're similar in age.
And they were turned on at the same time?
Well, they're very similar in that respect as well. Whichever one flew first was activated electronically back when it was put on orbit. They were both activated during 12A.1 operationally, okay. We call it. So yeah, they have very similar lives.
Okay. I think that wraps up all of our questions here at the Johnson Space Center and around the world. Just a reminder, a couple of programming notes. The coverage on NASA television of the spacewalk, assuming it remains scheduled for Thursday, will begin at 5 a.m. Central Time on Thursday. And we anticipate having a post-EVA briefing with Courtney as soon as we can get her off console for that, no earlier than 2:30 p.m. Central Time that day. Also, today we're going to be immediately following this briefing playing about 10 minutes more of that live footage of the practice session in the neutral buoyancy laboratory where a couple of spacewalking trainees are going through the motions of what will be required of Doug Wheelock and Tracy Caldwell Dyson when they set foot out the hatch to go do this repair work. With that, we will send you back to the NASA TV and the EVA preparations at the Neutral Buoyancy Lab, and look forward to covering the spacewalk when it starts on Thursday if plans hold there. Thanks very much for coming.